All right. So based on what we've discovered, we now know and have derived the law of sines. Okay, nobody had to tell us this. We derived it. So the law of sines says that if you take the sine of angle A and divide it by side A, it should be equal to the sine of angle B divided by the length of side B, which is equal to the sine of angle C divided by side C. And that works for any triangle. Oblique, scalene, isosceles, right, equilateral, equiangular, and so on. Provided that you either have two angles and an excluded side, or two angles and the included side, the one that's between them, or two sides and an excluded angle. And I wouldn't worry so much about what it works for. You'll be able to identify. Once you have a triangle kind of sketched out, you'll be able to identify what goes where and whether you can use the law of sines or not. Does that make sense? So we need to be aware that if we have an angle, a triangle ABC, the angles are always written in capital letters. The sides opposite those angles are written in lowercase letters with the same letters. Questions on this one? So far, so good? All right, so here we go. Put it into action. So we're asking you to solve triangle ABC. If angle A is 32 degrees, angle B is 50 degrees, and side C is 18.7. So what does it mean when we ask you to solve a triangle? Find all the angles and all the sides. So we know that we're going to have to find angle C, we're going to have to find side B, and we'll need to find side A. Okay? And if it helps you to draw the picture, draw the figure, B is 50 degrees, so it should be more than 45. A is 32 degrees, and again, this won't be necessarily to scale. And C, little side C, is 18.7. So if we try to set up proportions and we say the sine of 32 over A equals the sine of 50 over B is equal to the sine of C over 18.7, it looks like we have a problem. Got variables in every part, right? So what shall we do, Dang? We need to find the measure of angle C. Okay? Absolutely. Add them up and subtract them from 180. 50 and 32 is 82. So 180 minus that 82 is 98, right? So is my triangle drawn to scale? Absolutely not. Okay, and that's okay. Doesn't have to look perfect. But if you want to redraw it as an obtuse triangle, So it makes sense, the drawing makes sense, you can do that. Okay? All right, so we've got a 98-degree angle here. That means that, are you going to find A or B first? It doesn't really matter. What's your choice? A. Okay, so we're going to say the sine of 32 over A is equal to the sine of 98 over 18.7. Now we have three parts with just one variable. And we have to make sure that we put our calculator into degree mode. Okay? And before we do anything with the calculator, though, how do we solve a fraction equals a fraction? Cross multiply. So when we cross multiply, we'll take 18.7 times the sine of 32 is equal to A times the sine of 98. So let's figure out how we'll solve that for A. What do we need to do to get the A by itself? Divide by the sine of 98. Okay, so we're taking 18.7 times the sine of 32 and dividing it by the sine of 98. So what's A? Break out your calculator. What is 18.7 times the sine of 32 divided by the sine of 98? What you get? Does 10.0 sound about right? 0.0 what? Okay, so 10. Someone else collaborate that? Good. Okay, so A was 10. Angle C was 98. So now we just have to find B. Okay, and it's a good idea to make a little box off to the side so you know which three parts you're trying to find and you don't stop and forget to solve for something. Okay, so now we need to find B. Now, one of the things I do when I'm working these problems, I always try to go back to what I know, and I don't think we probably made a mistake when we found 98 degrees, right? So you could substitute 10 in for A, but it's usually a good practice to stick with what you had, the sine of 98 over 18.7, so that if you make a mistake, it doesn't snowball across everything. So we'll say that's equal to the sine of 50 over B. Okay, so now we cross multiply, right? B times the sine of 98 is equal to 18.7 times the sine of 50. So what do we do to get the B by itself? Divide by that sine of 98, right? And you plug that into the calculator, what do you get? 14? 14.5. Make sense? Okay. What if we had sides, but we didn't have the angle measure, and we're trying to find angle C, or angle B, or angle A? The inverse sine, exactly. Okay, so you may have to use your inverse sine button to get the angle back. Okay. All right, questions on this one? All right, next. We discovered this as well, right? The area of an oblique triangle, okay, has a formula. Area equals 1/2 side B times side C times the sine of angle A, or 1/2 AB sine of angle C, or 1/2 AC sine of angle B. And it works when we have side angle side. So we have two sides and the angle between them. Yep, it works for those. Exactly. Yep. All right, so far so good. So you may have to actually find some other pieces, right, in order to make this formula work. Okay? It's possible that you'll have two angles and the included side, right? And we have to find that third angle first before we can use it. Okay? All right, here we go. So find the area of triangle ABC. If angle C is 102 degrees, side B is 52 meters, and side A is 90 meters. This time we're finding area, not a side or an angle. So which of those three area formulas are we going to use? Exactly. So we're taking 1/2 of 90 times 52 times the sine of 102. Okay. So 45 times 52 times the sine of 102 gives us a pretty big number. What's it going to be? And then we're going to call that meters squared. Okay. And unless check to see what the directions tell you, but usually a good rule of thumb is if they've given you one decimal point, you're consistent and round to the tenths and so on. All right, so questions on this one? Okay, so today we're working part of 6-1, page 408, 5 and 8, and then skip count by threes, 15 through 21 by threes, 22, 39 to 41, 47, and 49.